Emeka. In this video session, we shall continue from where we stopped on our study of matrices. In this session, we shall discuss the equality of matrices. Then we shall also do some operations of addition and subtraction on matrices, addition of matrices and subtraction of matrices. And then we will solve some problems. I have the questions here on paper, so we shall discuss that and then we solve the problems. Okay, so let's begin with the equality of matrices. Equality of matrices. So say you have matrix A and matrix B. So if you have two matrices A and B, we say that mat A is equal to mat B. Sometimes you see mat as matrix. Sometimes you see it as mat. Mat A, matrix A is equal to matrix B if, number one, they have the same order or size. They have the same order, or some textbooks will write size. And number two, if their corresponding elements are equal. Corresponding elements are equal. Okay, so when you have two matrices, for them to be equal, they must have the same size, order, and then their corresponding elements are equal. Let's say maybe you have an A to be A11, A12, A21, A22. Okay? And you have B to be, matrix B to be B11, B12, B21, B22. So you have that A is equal to B if A11 is equal to B11. Okay, first of all, you have the order. This is 2 by 2 and this is 2 by 2. A is a 2 by 2 matrix and B is a 2 by 2 matrix. So they have the same order. So it satisfies the first condition. And then the second condition is that their corresponding elements must be equal. A11 must be corresponding with a B11. Okay. A12 will be equal to B12, A21 will be equal to B21, and then A22 will be equal to B22. So this is the condition for two matrices to be equal to each other. Yeah, they must have the same order and their corresponding elements must be equal. Now, let's go ahead now and look at the addition and subtraction of matrices. So addition and subtraction of matrices. The same condition that applies to equality, you know, especially with the first one. The first condition that applies to equality of matrices also applies to addition and subtraction of matrices. For two matrices to add or subtract, okay, for you to perform the operations of addition and subtraction of matrices, for you to perform the arithmetic addition and subtraction, arithmetic operations of addition and subtraction of matrices, they must be of the same order or size, And then the corresponding elements will now add or subtract. You know, the sum of these matrices will be the sum of their corresponding elements. And the difference of the matrices will be the difference of their corresponding elements. So you will see that the sum or the difference will still have the same order of the individual matrices. Okay? So we say that two matrices, say you have two matrices, A and B, okay, can be added if you can add the two matrices if, number one, they have the same order, they have the same size, okay, or order, okay, and then the sum will be, now I hope you know what is sum. Sum is the answer you get after addition. That is what we call sum. So the sum will be a matrix, okay, whose elements are the sums of the corresponding elements of the individual matrices. Okay, the sum will be a matrix whose elements are the sums of the corresponding elements of the individual matrices. Okay, we are using 2 by 2 for clarity. It can apply to 2 by 3, provided this is 2 by 3, 2 by 3, 3 by 2, 3 by 2, whatever order they have, it will work. So the sum will be that, and then the sum will have an order. The order of the sum will be the same order. The size of the sum will be the same size of the individual matrices. Okay? The size of the sum will be the same size as the individual, as the sizes of the individual matrices. So what we are saying is this. Look at what we are saying here. We are still using this. So say you have two matrices A and B. So we have that A plus B will be, okay, A11 plus B11, then A12 plus B12, A21 plus B21, A22 plus B22. So this will be the sum of the individual matrices, the sum of the matrices. And then of course the same thing applies to the subtraction as well. A minus B will be A11 minus B11, A12 minus B12, A21 minus B21, and A22 minus B22. Now what if we have B minus A? If we have B minus A, what do you think it will be? What do you think it will be? It will be B11 minus A11, B12 minus A12, B21 minus A21, B22 minus A22. That will be the difference. So in that case, I can twist the vocabulary here. You can subtract two matrices if you can subtract two matrices if they have the same size. That must be a condition. Okay? And then the difference now, this will be the difference. The difference, let me use blue marker. The difference will be a matrix whose elements are the differences. Whose elements are the differences of the corresponding elements of the individual matrices. The size of the difference, okay? The size of the difference matrix, the matrix that you get by subtraction will be the same size as the sizes of the individual matrices. So that is the thing about equality of matrices, addition of matrices, and subtraction of matrices. So we have talked English for a long time. Let us now solve some mathematics now. I didn't say math. I didn't say math. I said math. Okay. Decide whether each statement is true or false. Give reasons. All right. The first one, you have a by column. Let me say by column. If it's, when I took this class in school, actually I took this in high school. Yes, high school. Further mathematics. We called it further mathematics. So sometimes the professor will call the elements by row or by column. Okay. So if I'm calling by column 2, 7, 5, 4. Okay, the professor will tell you the size of the matrix or the order of the matrix, and then call the elements for you, either by column or by row, just for you to know how to write it, is equal to 2, 7, 4, 5. Okay, is this true or false? This question. Is this matrix, is it true or false that this is equal to this? They have the same size. This is 2 by 2, this is 2 by 2. So the first condition is satisfied. But their corresponding elements are not equal. Now, A11, assuming this was A and this was B. A11 is equal to B11, that's fine. 2 is equal to 2. But 5 is not equal to 7. Okay? 7 is not equal to 4. And 4 is not equal to 5. So because of that, it's false. This is false. False. Okay, because of these reasons. Their corresponding elements are not equal, period. The corresponding elements are not equal. Corresponding elements of the matrices are not equal. Are not equal. Okay, number 2, you have this by row. Let me call this by row. This is a column matrix. Remember what we did in column matrix in the previous video. And this is a row matrix. -3, 2, 4. Now look at this case, right? Are they the same? Is this true or false? Now, don't be tempted to say that it's true. You make a mistake if you say that it's true. Because first of all, they don't have the same what? They don't have the same size. This is what? What's the size of this? 3 by 1, right? And this is what? 1 by 3. Okay, so because of this, it won't be equal. Okay, so now they could multiply themselves when we do multiplication of matrices. Probably in the next video session we'll do that. Okay, but you can't, but they are not equal. They are not. because they don't have the same size. They do not have the same size. They do not have the same size. So if they don't have the same size, you can't even talk about equality at all. You can't. I mean, the first condition is the basic that must be got, that must be established. The basic that must be established. Okay, next question. Question 3. Solve for the variables if. Solve for the variables. Solve for the matrix variables. If you have 2, 4, 1, A is equal to A1, B, C. Okay, they want you to solve for the variables. What are the variables here? A, B, C. So you check it first. This is 2 by 2. This is 2 by 2. This is 2 by 2. So first condition is satisfied. And then, of course, you now apply the equality of matrices. So when we apply that, A will be equal to 2. Okay? 1 is equal to 1, which is correct. And then B is equal to 4. And then C is equal to 8. Now let me ask you something. What if this was 5? It would be a problem. This would be a contradiction. If this was a 5, then it would be contradiction. Because 1 is not equal to 5. So take note of that. Okay? It would be a contradiction if it was equal to 5. You can't say they are equal why they are not equal. In one basis you say they are equal, in the other basis the corresponding elements are not equal, then it will be contradiction. So it must be equal to 1. Another thing I want to ask you, what if you had it like this? What if you had it like this? Okay? This is also a contradiction because this is 2 by 2 and this is what? 2 by 1. 2 by 1 now. So it will be a contradiction. So it won't work. Okay? So it must be those two. It must be those two that must be satisfied. Must. And then you have it. Okay. Question 4. Let's put it here. This is pretty simple, right? Very simple, right? Question 4, you have a 7k equal to 7,5. Of course, you know what it means now. So k will be equal to what? 5. That's it. Question 5, now this must be 7 for it to work. Question 5, you have this. 2, 4 by row, 2, 4, P minus 2, 2Q minus 2, 3, 2, 2R, negative 3, 2, equal to 2, 4, 5, 3, A, 2, 4, negative 3, 2. Okay, so how do you see, you solve it. This is a 3 by 3. This is 3 by 3, which is good. This one is what? 2 by 1. 2 by 1, 2 by 1. Okay, so, and this is 4, this is 2, 4, which is good. Okay. This is 3, 2. This is 2, which works. And this is negative 3, 2. This is negative 3, 2. Okay, so how will you find it? We now have that. This is just equation, linear equation that you've done before. Okay, so when we compare that, we have that P minus 2 is equal to 5. P minus 2 is equal to 5. So P is equal to what? 5 plus 2, P is equal to 7. Now, if you don't understand it, view my video on linear equations. The next one, 2q minus 2 is equal to 3. So 2q will be equal to 3 plus 2. 2q is 5. So q will be 5 over 2. Okay? Then you have that 3 is equal to a. Yeah, 3 is equal to a. So a is equal to 3. Okay? And then you have that 2r is equal to 4. So r is equal to 2. Yeah, you know why the variables are on the left-hand side? I mean, written b. Instead of saying 3 equal to a, I said a equal to 3. I did that on my videos, so you can view it. Okay, so that's question 5. Question 6, let's see whether we can do question 6 here. You want to add this. Add, okay, or perform the indicated operation. Perform the indicated operation. Perform the indicated operation. So you have a, okay, I need to have space to kind of write this. So I have a matrix that is kind of a bit big. Yeah, so question 6 back here, you have by column 1, 3, 1, 3, 2, 0, 5, 2, negative 1, negative 4, plus 8, negative 2, 10, negative 1, negative 5, 4, and 3, 5. Okay, so this is the question to want to add it. So this is what? 1, 2, 2 by what? 2 by 4. And this is what? 2 by 4. So they are the same size. Okay? So the addition will now be 1 plus 8. Look, I would suggest that you do it step by step. Don't rush. Okay? 1 plus 8, 2 plus 10, 5 plus minus 5, 5 plus minus 5, minus 1 plus 3. And then you close this. Okay? So this is 3 plus minus 2, 0 plus minus 1, 2 plus 4, and then minus 4 plus 5. Alright, so this will now be what? 1 plus 8 is what? 9. 2 plus 10 is what? 12. Now, what I taught you, what did I teach you? When you see two signs together, make it one sign first. Okay? So this will be 5 minus 5. I am doing it step by step so that I don't make a mistake. I'm doing it step by step so that I do not make a mistake. Negative 1 plus 3, 2. Then this is what? 3 minus 2. You see two signs, make it one sign. This is 0 minus 1. This is 6, and this is 1. Alright? So this will be, now I know that some of you, you are very good at mental math. I am too, but I want to consider all my students. So this is 9, 12, 0, 2, 1, negative 1, 6, 1. So 9, 12, 0, 2, 1, negative 1, 6, 1. Question 7. Perform the indicated operation. Let me call by row. 2, 8, 12, 2, 7, 4, negative 1, 5, 1, 3, 0, 10, minus 1, 3, 7, 9, 2, negative 3, 2, 4, 8, 5, negative 3, 27. Okay, so this is a 1, 2, 3, 1, 2, 3, 4, 3 by 4, 3 by 4. So they have the same size. So we go ahead and add them. We go ahead and add them. This will now be 2 minus 1, 8 minus 3, 12 minus 7, 2 minus 9. You have to be very careful. This is simple, but you have to be careful. Okay? Now this is 7 minus 2, 4 minus 3, minus 1 minus 2, 5 minus 4. Then this is 1 minus 8, 3 minus 5, 0 minus 3, and 10 minus 27. So this will be 2 minus 1 is 1, 8 minus 3 is 5, 12 minus 7 is 5, 2 minus 9 is minus 7. 7 minus 2 is 5. This is 4 plus 3. I know it's 7, but I want to do it step by step. This is negative 3. Minus 1 minus 2 is minus 3. 5 minus 4 is 1. 1 minus 8 is minus 7. 3 minus 5 is minus 2. Then this is 0 plus 3. And then 10 minus 27 is minus 17. Okay, so you finish it up. This will be 1, 5, 5, negative 7. 5, 7, negative 3, 1. Negative 7, negative 2, 3, negative 17. And that becomes your answer. Let's do some algebra, you know. Yeah. We have this m, negative 2, 3n, plus negative 2p, negative 1, 2. Okay, that's by row. Equal to, by row, 4, negative 2, 2q, 4. So this is both an addition and equality of matrices. Both of them. It is both of them. Both addition and equality of matrices. So how do we solve this? Now, some of you rush. But if you very good at mental, good. But don't make mistakes. Yeah, but you know, for the purpose of teaching to an audience, I will have to consider all the audience. So I have to start from the low level to get them up to an acceptable level. So if we go ahead and do this, this is of course, all of them are 2 by 2, 2 by 2, 2 by 2, 2 by 2. Okay, so we have m plus minus 2, minus 2 plus p, and 3 plus minus 1, n plus 2. And that will give us 4, negative 2, 2q, 4. I can go ahead and, you know, go ahead and solve it. So m plus minus 2 is equal to 4. So m minus 2 is equal to 4. M will be 4 plus 2, and m will be equal to 6. That is taken care of. Next one, negative 2 plus p is equal to negative 2. So p will be negative 2 plus 2. P will be 0. Okay? Next one, 3 plus negative 1 is equal to 2q. 3 minus 1 is equal to 2q. 2 is equal to 2q. 2q is equal to 2. Q is equal to 2 divided by 2. Q is equal to 1. Okay? And then the last one, n plus 2 is equal to 4. N will be 4 minus 2. N will be 2. Okay? Okay, that's question 8. Question 9 is the next one. You have the same similar one. This is by row C plus 2, 3D plus 1, 5E, 4P, 0, 3, plus by row 3C, 2D, 5E, 2P, 5, 6. Let me call this one now by column. 10, 10, negative 14, 5, 89. Okay. So, I mean, if you want to do this like this, that's fine. Some folks don't want that. Some folks will go ahead and do C plus 2 plus 3C is 10. Some folks will just do it that way. So, I think I mean, if you want to do it that way, there are so many ways to dance, you know. You can do break dance, you can do electric dance, you can, come on. Okay, so we can go ahead and do it like that. It doesn't matter, you know. C plus 2, then this plus is this plus 3C will give us 10. I mean, if you know. But now, if you have minus here, just be careful. That's the only thing I would suggest, you know. So this is 4C plus 2 is 10. 4C will be 10 minus 2. 4C is 8. C is 8 divided by 4. C is 2. I mean, this is another way to do it. Another way to do it. But if you want to be careful, you do it step by step. You know, you can do it that way. Next one, we have 3D plus 1, then plus 2D is equal to negative 14. This here plus this is equal to this. Yeah. Just be careful on this. And if you have minus here, you have to be careful. There's no minus, but if we had, you have to be careful, you know. So 3D plus 2D is 5D plus 1 is negative 14. 5D will be negative 14 minus 1. 5D is negative 15, and D is negative 3. Okay? Next one, this one, 5E plus 5E is 80. So this is what? 10E is 80, and E is 8. Yeah. I didn't write the order here. What is this order? 1, 2, 1, 2, 3. 2 by 3. Okay, this is 2 by 3. They must have the same order, 2 by 3. Yeah. Then the next one, 4P. 4P plus 2P will give us 10, right? 4P plus 2P is 10. So 6P is 10, and P will be 10 over 6, which is what? 5 over 3. P is 5 over 3. Then the next one, 0 plus 5. 0 plus 5 is 5. It says it. It says it already. 0 plus 5 is 5, of course. Then the next one is what? 3 plus 6 is 9. Okay. It says it already. Okay? And that's the answer. Now, you can do it another way. I mean, it's up to you. Okay, last but not the least, question 10. Perform the indicated operation 4n minus 8n, 6a minus 3b, 2p plus 5q, minus 4u plus 2w, minus 5m plus 6n, 2a plus 5b, 4p plus 6q, 4u minus 2w. Okay, how do we solve this, folks? What's the order here? 1, 2, 3, 1, 2, 3, 4, 1. 4 by 1. Okay? And this is 4 by 1. So they have the same order. So we got, now, this is an entity. This is an entity. Okay? 4m minus 8m. We can't call it like it's 2 elements. It's 1 element. Okay, so let's go ahead. This will now be what? 4m minus 8n minus. You put your parentheses now. Be careful. You don't just do minus 5m plus 6n. No, you don't do that. You have to put your parentheses 5m plus 6n. Okay, you close that. Then this is 6a minus 3b minus 2a plus 5b. This is a 2p plus 5q minus 4p plus 6q. And this is a minus 4u plus 2w minus 4u minus 2w. Okay? So this will be 4m minus 8n. You apply your distributive property. Distributive property. This is minus 5m minus 6n. Okay? 6a minus 3b minus 2a minus 5b, 2p plus 5q minus 4p minus 6q minus 4u plus 2w minus 4u plus 2w. So be careful of your signs always. Always be careful of your signs. Okay? So what we got now? We now have if you want to simplify this more, if you want to simplify it very well more, I mean, you can always skip this step, but if you want to simplify it more, you can say 4m minus 5m minus 8n minus 6n, 6a minus 2a minus 3b minus 5b, 2p minus 4p plus 5q minus 6q minus 4u plus 2w minus 4u, minus 4u minus 4u plus 2w plus 2w. Okay? If you want to simplify it very well. So we just gather the like terms, you know. I know you learned this in your 6th grade. With the cell, you gather the like terms. This is now negative m, negative 14n. And this is a 4a minus 8b. Okay? This is a minus 2p minus q. And this is minus 8u plus 4w. Okay? Now, some folks will just look at this and say the answer. You know, 4m minus 5m is minus m, minus 8n minus 6n minus 14n, 6a minus 2a, 4a, minus 3b minus 5b minus 8b, 2p minus 4p minus 2p, 5q minus 6q minus q, minus 4u minus 4u minus 8u, 2w, minus minus, plus 2w, 4w. Some folks will say, Mr. C was just wasting his time. Okay, I am considering a large audience. Okay, now you see that this is what? This is 4 by 1. It's 4 by 1. It will have the same order as the order of the individual matrices. Thank you so much for listening to this video presentation. In the next video, we will look at a multiplication of matrices, scalar multiplication, and matrix multiplication, so that this video does not get long. So thank you so much for listening.